Bismillahirrahmanirrahim. Assalamu alaikum, dear students. As you know, we are studying mathematics for class 11, and it's chapter number 7, which is permutation, combination, and probability. Today, in lesson number 4, we will study combination, and we will solve some questions of exercise 7.4. These questions are included in your reduced syllabus. And you have also to solve example number 1, 2, and 3. Combination. A combination of a collection of n objects taken R at a time is any selection of R of the objects where order does not count. Order is not important. A combination of n objects taken R at a time is denoted by NCR and is given by the formula NCR is equal to n factorial over r factorial into n minus r factorial. Earlier in the previous lesson, we have defined permutation. Permutation is the number of arrangements of n objects in which order is important. Here in combination, order is not important. NPR was equal to n factorial over n minus r factorial, but NCR, combination of n objects taken R at a time, is equal to n factorial, the total number of objects, over r factorial, the number of objects which we take at a time, and the difference between the total and the r and its factorial. This formula is important, and this formula is asked in MCQs. If R is equal to n, then NCR is equal to 1. This is important for MCQ point of view. NCN is equal to 1. And if R is equal to 0, then NC0 is equal to 1 also. NCN is equal to 0 and NC0 is equal to 1 also. These are important for MCQs. Difference between permutation and combination. How you will differentiate between permutation and combination from the statement of the question. Order counts with permutations such as the words, if in the statement the words sitting in a row or in a line and electing a president, vice president, and treasurer etc. Order does not count in combination. Order does not count with combinations such as committees and teams without counting position. If you are asked to find a number of committees or number of teams from a given number of objects, then it means you are asked to find the combination. Otherwise, if you are asked to arrange the objects in a row or line, or you are asked to select a president, a vice president, a treasurer, a monitor, etc., then you will solve the question by using the formula of permutation. Sum rule principle of combination. Suppose some events E can occur in P ways and a second event can occur uh, in Q ways, and so on. And suppose all events cannot occur simultaneously, then E and F can occur in P plus Q ways. Then E or F can occur in P plus Q ways. And product rule principle of combination. Suppose some events E can occur in P ways, and independent of this event, an event F can occur in Q ways, and so on. Then the combination of events E and F can occur in P and Q. If there is a word and between two events, then you will multiply the combination of those two events, and if there is a word or between two events, then you will add the combination of two events, where P is equal to NCR1 and Q is equal to NCR2. Complementary combination. The number of combinations of n objects taken r at a time is equal to the number of combinations of n objects taken n minus r at a time. That is, the number of combination of n objects taken r at a time is equal to the number of combination of n objects taken n minus r at a time, and this is equal to ncr is equal to nc n minus r. So this is also important for examination point of view. If there is a 5 and there is 3, then 5 combination of 5 things taken r at a time, taken 3 at a time, is equal to combination of 5 objects taken 5 minus 3, that is 2 at a time. In exercise 7.4, you are asked to evaluate the following in question number 1, that is calculate 12C3, combination of 12 objects taken 3 at a time. So we know its formula, 12C3 equals to 12 factorial over 12 minus 3 factorial into 3 factorial. Simplifying this, we get 12 factorial over 9 factorial into 3 factorial, or 12, 11, 10, 9 factorial over 9 factorial multiplied by 3 factorial. This 9 factorial is cancelled with this 9 factorial, and we are left with 12 into 11 into 10 over 3 factorial. 3 factorial means 3 to 1, 6. Or you can cancel 12 by 6 and then multiply 2 into 11 into 10 to get the answer, and the final answer is 220. Then calculate 20C17, combination of 20 objects taken 17 at a time. This is equal to 20 factorial over 20 minus 17 factorial into 17 factorial. 20 factorial over 3 factorial into 17 factorial, and this is equal to 20, 19, 18, 17 factorial over 3 factorial into 17 factorial. This 17 factorial is cancelled with 17 factorial, and we are left with 20, 19, 18 over 3 factorial. Again you can expand this, simplify 3 factorial, which is 6, or multiply the numerator and divide by 6. The final answer is 1140. NCR. Now there is no fixed number. It is general. NCR. We will write n factorial over n minus 4 factorial into 4 factorial. Now in the denominator there is n minus 4 factorial, so you can write n factorial up to n minus 4 factorial. It is n into n minus 1, n minus 2, n minus 3, and n minus 4 factorial over n minus 4 factorial into 4 factorial. This n minus 4 factorial is cancelled with this n minus 4 factorial, and we are left with n into n minus 1 into n minus 2 into n minus 3 over 4 factorial, and this is your final answer. These questions may be asked in MCQs always. 12C3 is equal to 220, or 20C20 is equal to 1140 option. Find the value of n when this equation is given. NC5 is equal to NC4, complementary combination. We have just studied the formula. NC5 is equal to NC4. Since NC5 it is given, NC5 is equal to NC4, we can write NCn minus 5. This is equal to NC4, because NC5 is equal to NCn minus 5, the difference of these two, which is the complementary combination, and this is equal to this. Now because these two are equal statement, left hand side and right hand side are equal, comparing these two we get n minus 5 is equal to 4. This is the complementary combination which we have just studied. So using this rule we can equate and get n minus 5 is equal to 4. Solving this we get n is equal to 4 plus 5 and n is equal to 9. This is important question for your short question point of view. The second part is NC10 is equal to 12 multiplied by 11 over 2 factorial. Now simplify this. We can write NC10 12 into 11 into 2 over 2 factorial. This is given. We can write this as 12, 11, 10 factorial over 2 factorial into 10 factorial. Complete the factorial on a right hand side. So this is equal to NC10 12 factorial. The larger number is 12. In the denominator 2 can be written as 12 minus 10 factorial and 10 factorial. So here n is equal to 12. N is equal to 12 because its expansion will is n factorial over n minus 10 factorial into 10 factorial. So n is equal to 12. Again NC12 is equal to NC6. It is of same type question. So NC12 is equal to NC6, it is given, and this is equal to NCn minus 12. This is equal to NC6 because NCr is equal to NCn minus r. So NC12 is equal to NCn minus 12, and we put this equal to right hand side. Now comparing these two, we get n minus 12 is equal to 6 and n is equal to 18. Question number 3, you are asked to find the value of n and r when these two equations are given. Using these two equations, we will find the value of n and r. We know that when we need to find the value of two unknown, we need two equations, and we will solve those equations simultaneously. Using this equation NCr is equal to 35, we get n factorial or n minus r factorial into r factorial is equal to 35. We can write this as n factorial over n minus r factorial is equal to 35 multiplied by r factorial. This r factorial is multiplied with 35 and we call this as equation number 1. Now using this second condition, equation npr is equal to 210. This is the permutation. We know that npr is equal to n factorial over n minus r factorial, and this is equal to 210. Now n factorial over n minus r factorial is equal to 210 and n factorial over n minus r factorial is equal to 35 into r factorial. Using these equating these two equations, we get 35 r factorial is equal to 210 because left hand side of equation number 1 and left hand side of equation number 2 are same, so their right hand sides will also be equal. So that is 35 into r factorial is equal to 210, or r factorial is equal to 210 over 35, and r factorial is equal to 6, and 6 can be written as 3 factorial. R factorial is equal to 3 factorial, so it means the value of r is equal to 3. We are able to find the value of r. Now we will put this value of r in equation number 2 in this equation. Putting value of r in equation number 2, we will get n factorial over n minus 3 factorial is equal to 210. Now in the denominator there is n minus 3 factorial, so write n factorial up to n minus 3 factorial. So it is n into n minus 1, n minus 2 into n minus 3 factorial over n minus 3. N minus 3 factorial is cancelled with n minus 3 factorial, and we get n into n minus 1 into n minus 2 is equal to 210. We can write 210 as a product of three consecutive numbers, and these numbers are 765. N into n minus 1, n minus 2 is equal to 7 into 6 into 5. So it means the value of n is equal to 7, the largest number. So this implies that n is equal to 7. So the value of r is equal to 3 and value of n is equal to 7. Question number 4. How many diagonals and triangles can be formed by joining the vertices of polygon having? We know that polygons are a closed figure made up of 3, 4, 5, 6, 7, 8 sides. Or that is, triangle is a polygon, quadrilateral is a polygon, pentagon is a polygon. You are asked to find the number of diagonals and the number of triangles which we can form by from the polygon of 5 sides. If a polygon has 5 sides, so it will have 5 vertices, 5 corners. 5-sided polygon has 5 vertices. Diagonals are the lines which we join, which is obtained by joining the opposite corner, opposite vertices. So there are 5 sides of the triangle and there will be some diagonals. So we will find total number of sides of the 5-sided polygon, in which fives are sides and the remaining will be polygon. And we know that one side is obtained by joining 2 vertices. If this is a triangle AB, then A and B, when we join A and B, we get one side. B and C, we get other side. C and A, we get other side. So there are 5 vertices. If we will join 2 vertices, we will get one side. So number of line segments is equal to 5C2. If out of 5 vertices we join 2 vertices, we get a line. So how many lines will be there? Simplifying this, it is 5 factorial over 2 factorial into 5 minus 3 factorial. So simplifying this, 5 factorial over 2 factorial into 3 factorial, and then calculating, we get 10. So there are 10 total number of lines in a 5-sided polygon, and these 10 lines includes 5 sides and other the remainings are the diagonals. So number of diagonals will be equal to 10 minus the number of sides of the polygon, which are 10. So 10 minus 5 is equal to 5. 5 are the, out of these 10 lines, 5 are diagonals and 5 are the sides. Now in B part you are asked to find the number of triangles. We know that when 3 vertices are joined, we join 3 points, we get a triangle. Now there are 5 vertices of a 5-sided polygon. So we will take 3 out of 5 at a time. So number of triangles by joining any 3 vertices is equal to 5C3, because to form a triangle we will have to join 3 out of 5. So 5C3 is equal to 5 factorial over 3 factorial into 5 minus 3 factorial. Simplifying this, we get 10. So there are 10 number of triangles in a 5-sided polygon. 8-sided polygon. We know that 8-sided polygon will have 8 vertices. So number of line segments in a polygon having 8 vertices is 8C2. Mean 8 factorial over 2 factorial into 8 minus 2 factorials. Simplifying this, we will get 28. So there are 28 triangles, 28 line segments in a polygon having 8 sides. So out of these 28, 8 are the sides of the polygon and remaining will be the diagonals of the polygon. So number of diagonals is equal to 28 minus 8, and this is equal to 20. Similarly, 8-sided polygon has 8 vertices, and in making the triangle we need to join 3 out of this. So we will form the combination of 8 taken 3 at a time. 8c3 is equal to 8 factorial over 3 factorial, 8 minus 3 factorial, 8 factorial over 3 factorial into 5 factorial. Simplifying this, you will get 56. So you can form 56 triangles inside a polygon having 8 sides. Similarly, you can solve its third part in which there are 12 sides. So to find the number of line segments, we will take the combination of 12 taken 2 at a time, and this is equal to 66 total line segment. Out of 66, if you subtract the 12 which are the sides of the polygon, you will get the number of diagonals, which is 54, and you will take the combination of 12 taken 3 at a time to find the number of triangles. It is 12 factorial over 3 factorial into 12 minus 3 factorial. Simplifying this, you will get 2200. Question number 9. There are 8 men and 10 women members of a club. How many committees of 7 can be formed having 4 women? So it means if you form a committee of 7 members in which there are 4 women, so how many men will be there? There must be 3 men. So a committee of 7 persons having 4 women and 3 men. So this is the case of multiplication of combination. So number of men 8, number of women 10, committees of 4 women out of 10 and 3 men out of 8 is equal to 10 C4, that is 4 women out of 10 multiplied by 3 men out of 8. Combination of 10 taken 4 at a time and combination of 8 taken 3 at a time, and we will multiply these two combinations. So it is 10 factorial over 4 factorial into 10 minus 4 factorial multiplied by 8 factorial over 3 factorial, 8 minus 3 factorial. We have used the product rule principle of combination, which we have studied in the previous slides. So simplifying this, we will get 210 this one and 36 this one. Multiplying these two, we will get 11760. You can further simplify by using one or two more steps, or use a calculator to find 210 and solve this to get 36. Question number 10 is normally set in long questions, but it is included in your smart syllabus, so we will have to solve this. This is proof that NCR plus NCR minus 1 is equal to N plus 1 over CR, combination of N plus 1 objects taken R at a time. We will solve left hand side and right hand side, and we will show that both the answers are equal, or we will solve left hand side and we will prove that after simplification we get the answer which is right hand side. So taking its left hand side, NCR plus NCR minus 1, simplifying using the formula, we get n factorial over n minus r factorial into r factorial plus n factorial over n minus r minus 1 factorial into r minus 1 factorial. So this is n factorial over n minus r factorial as it is, plus n factorial. Removing this bracket, we get n minus r plus 1 factorial, r minus 1 factorial with this. So this is n factorial, n minus r factorial, expand this r factorial, r into r minus 1 factorial, because this second fraction has r minus 1 factorial in the denominator, plus n factorial, n minus r plus 1 and n minus r factorial, because First fraction has n minus r and r minus 1 factorial. Now this is common, n factorial over n minus r factorial into r minus 1 factorial is common in both the fractions, and we are left with 1 over r plus 1 over n minus r plus 1 within the bracket. Now take the LCM of these two. N r into n minus r plus 1 is LCM, and we get n minus r plus 1 plus r. This plus r is cancelled with the minus r, and we get n plus 1 in the numerator and r into n minus r plus 1 in the denominator. Now multiplying this and this, we get n plus 1 into n factorial. In the denominator, n minus r plus 1, this one, n minus r factorial, this one, r and r minus 1 factorial. This in the numerator we can write this as n plus 1 factorial, and this is n minus r plus 1 factorial, because larger number of these two is n minus r plus 1, and from here r is the larger of these two, so we get r factorial. So n plus 1 factorial in the numerator, n minus r plus 1 factorial multiplied by r factorial, and we can write this as n plus 1 factorial over n plus 1 minus r and r factorial, and this is equal to n plus 1 cr, n plus 1 factorial difference of these two, n plus 1 minus r factorial and r factorial. So this is equal to n plus 1 cr, and this is your right hand side. Keep doing practice, because practice makes knowledge perfect. Thank you for watching, and Allah Hafiz.